Lecture 18, Rotations. Rotations are very important in structural geology. On the StereoNet, we can do two types of rotations: rotation about a vertical axis, and rotation about a horizontal axis. This figure shows the rotation about a vertical axis pointing downwards. Figure A shows this type of rotation in 3 dimensions. In this case, we are rotating a line clockwise 40 degrees. Note that the line changes in trend but not in plunge. Figure B shows the line, L, on the StereoNet. The lines has trend 130 and plunge 40. If we rotate the line 40 degrees clockwise about a vertical axis pointing downwards, the new orientation of the line, L', is trend 170 and plunge 40. The line increases in trend 40 degrees but its plunge is still the same. This is the StereoNet with the overlay rotated back to the north, and the two lines, L and L'. So rotating a line about a vertical axis changes the trend of the line but not its plunge. This figure shows a line, L, rotated clockwise about a vertical axis pointing downwards, in increments of 30 degrees, starting with increment 1. Notice that the line changes in trend but not plunge. At any increment, the distance of the line to the center of the net is the same. The second type of rotation we can do on a StereoNet is a rotation about a horizontal axis. This is illustrated in this figure. Figure A shows this type of rotation in 3 dimensions. About the strike line of the plane, which is north, we can rotate the plane counterclockwise or clockwise. If we rotate counterclockwise, the plane decreases in dip. If we rotate clockwise, the plane increases in dip. Note that in both cases, the strike of the plane remains the same. Figure B shows the counterclockwise rotation on the StereoNet. The plane keeps its strike but decreases in dip. Every point on the great circle of the original plane, here in blue, moves along a small circle in the net to the new plane orientation, here in red. The pole to the plane also moves along a small circle towards the center of the StereoNet, from P to P'. Figure C shows the clockwise rotation on the StereoNet. The plane keeps its strike but increases in dip. Every point on the great circle of the original plane, here in blue, moves along a small circle in the net to the new plane orientation, here in red. The pole to the plane also moves along a small circle towards the primitive of the StereoNet, from P to P'. Here is a line, L, rotated clockwise about a horizontal axis pointing north, and in increments of 30 degrees. Note that as the line is rotated, it moves along a small circle in the net. Rotations are extremely useful in geology. Here is one example: an overturned bed is oriented north 30 west, 40 southwest. A current lineation on the bedding plane has a rake of 30 northwest. What was the orientation of the lineation when the bedding was horizontal? This kind of problem is very important because we cannot report the direction of the current lineation as it is today on the overturned plane. We need to rotate the plane back to its original horizontal orientation, and the lineation with it, to determine the orientation of the current that deposited the bed. First, we draw the plane and the current lineation. Then, we rotate the overlay to make the strike of the bed fall on a vertical straight line on the net. The rotation axis is RA. Then, we rotate the plane and the lineation to their original orientation before tilting of the bed. Note that the bed is overturned, so it should be rotated anti-clockwise about the rotation axis, past the vertical. Finally, we rotate back the overlay. The orientation of the lineation, L', when bedding was horizontal is north. This is the direction of the current that deposited the bed. We'll do more exercises like this in class. We'll also look at how to perform rotations using linear algebra and computation. To learn more about this, read Chapter 6 of Marshak and Mitra, or Reagan, and answer these questions.